Alright, so here is a lecture on coastal wave processes and sea protection. Alright, just to orientate you first, you are facing right now the Andaman Sea. How big the Andaman Sea is, where it is, go check out your textbooks and see the size and the scope of the Andaman Sea and the size of its fetch. Now, right now you are looking at what is a headland-ish kind of a feature. We are on a headland, so to speak. In the screen on the opposite side you can see the other headland, and as we pan around you can see that there's an indentation, and that is the bay. Alright, so what we are facing right now essentially is a headland facing the Andaman Sea. Now, another thing I want you guys to take note of is the length of the fetch. Alright, you can clearly see there's nothing else across the horizon, so the fetch is very, very long. The next thing also is for you guys to see the colors. Alright, you have what is a lighter shade of green and a darker shade of green further on. So the lighter shade of green is because there's a lot of sediments being moved over from the beach that I showed you a little bit earlier. Alright, so that gives its light green color. Of course, further on, less sediments and a deeper ocean. Also, the next thing I want you to take note of is how relatively calm the waters are. Alright, the wind is not very strong. I'll just pan over and show you a flag. Alright, the wind is not very strong. But what I want you to take note of is just how strong the waves are. Now, conventional wisdom dictates that strong waves are caused by strong wind. Now, over in this location by the way is Khao Lak in Thailand. Over in this location you realize that wind and waves have very little correlation whatsoever. This is June, right, somewhere in the middle of June. So what you are getting right now is the southwest monsoon. All this water and waves that you are looking at right now does come from the southern regions because it's northern low pressure. So somewhere off the sea there is a wind, it's blowing south to north, and that is what is causing all these waves that you are seeing. But the strong waves that you're looking at right now is a cause of the coastal protection measure. And I'm about to show you what the coastal protection measure is right now. Now, if you notice in the middle of the screen, you will see a walkway. Now, that is not really a walkway, that is a seawall. Note the width and the depth of the seawall. That is how thick it is. Now, this seawall is vertical. I'll try and get close to the seawall. This seawall is vertical. So what you're essentially getting is a cliff. Alright, and what you're seeing, alright, is the waves, and I better move back before the waves crash on me, crashing onto a vertical cliff, having nowhere to go, no space for swash, 100% backwash, and causing the massive crashes that you see. Also, if you pay attention close enough, and I'm about to get wet, if you pay attention close enough, you will see that actually the backwash crashes into the incoming swash, causing breakers off a little bit off the seawall. Alright, and that turbulence is the thing that's causing all the frothing that you see right now. So, actually, the coastal protection measure is causing an increased amount of erosion right at the location where it is supposed to be protecting. Now, let me see if I can get it over there. Alright. Now, if you know how high the waves get to, right, you will see that that is because the wall presents no space for the swash to go to, and what happens is that it interferes with the incoming swash. So the backwash interferes with the incoming swash, and that pushes the waves higher up. Now if you were to pan over and look at the bay area, you will see very little wave action going into the bay. So that's concentration around this headland area, very little energy going into the bay. Alright, so this concludes coastal processes and protection measures.